Hello. We're doing it a little bit different today so that I can show you how I spin my paper a little bit for rotation. So this is 2.02 geometry notes. And we're going to, just reposition a little bit here. Okay. So nice clean space. This is going to be rotations for our notes. So we have rotations are a turn or spin. When you take a figure and you turn it or spin it in the plane. So the notation for that is a capital R. Remember, reflections are little r, lowercase r. So I always remember big rotation is capital R and reflection is little r. The first thing right here, the sub letter O, tells us the center. So that's telling us that our center is at the origin, and then tells us how many degrees we want to rotate. The thing you need to remember with rotations is that if it is positive degree, so positive 90, you're going to go counterclockwise. And if it is a negative degree measure, then you're going to go clockwise. And then you would have your point right here for your pre-image. Next is this an isometry and a rigid motion. So remember, isometry and rigid motion really mean the same thing. It means, does the size of the image stay the same? And with a rotation, the size does stay the same. And what we always remember with rigid motion is distance and angle measure are preserved. As for orientation, we want to know, do the vertices stay the same in the same order, or are they the opposite order? And with a rotation, even though you're spinning it around, it's going to stay in the same order because you're not reflecting it. So it would still be direct orientation. The only one that's opposite is your reflection that we've talked about. So the order of your vertices stays the same, meaning if you go from A to B and it's clockwise, then in the image, you would again go from A to B and it would still be clockwise. Number 1 now, I want you to plot the point A, which is 2, 3. So I'm going to take my ruler now and draw a set of axes. Okay, so we have 2, 1, 2, 3. That's our point A. This is our y-axis and our x-axis. So I'm going to do 3 parts to this question. Part A is going to be that I want to rotate this point about the origin. It's so important that you put that O there, or whatever point you're rotating about right there. On the Regents exam, if you don't write that, you will lose points every single time. All right, so I want to rotate 90 degrees. Since it's positive 90, that tells me I want to go counterclockwise. So counterclockwise. Let's take this point, and I'm going to actually take my entire paper and I'm going to rotate it counterclockwise. So I'm going to rotate it counterclockwise. And now I'm treating this right here as my new y-axis and this as my new x-axis. I'm not plotting anything though. All I'm doing is I'm going to count the boxes to see what the coordinates of this point would be on this new set of axes. So 1, 2, 3, that's -3 up 2. So if you want to, you can even write that down, -3, 2. And then you're going to flip your paper back to the home position. Now you're going to plot the point -3, +2. And that'll be your A prime. So what we did, if I connect this point to my center of rotation, which is the origin, and I connect my image to the center of rotation, you should see here that you create a nice right angle. and it's being rotated counterclockwise 90 degrees. So your answer would be -3, 2. The next one, I want to rotate about the origin. So the origin is my center, -90 degrees, the same point, 2, 3. Okay, so if you want to use colors, you can, or just labels should be fine too. So here I'm going to take my original point again, A, and I'm going to rotate it -90. So if it's negative, that tells me I want to go clockwise. CW for clockwise. So I'm going to take my whole paper and I'm going to rotate it 90 degrees clockwise. Now I'm going to look at this point here, my original point. I'm not writing anything down. I'm just counting the boxes and treating this as my new x-axis and this as my new y-axis. So I'm going over 1, 2, 3 to the right and down 2. So that's 3, -2. So onto my graph, I'm going to go back to home position and go over 3, down 2. And that's going to give me a double prime. And my last one I want to do is I'm going to rotate about the origin 180 degrees, the point 2, 3 again. Okay, so this one, I'm taking my original point, and this time it doesn't matter with 180, but since it's positive, let's get in the habit of going counterclockwise. We go 180 degrees, that's 90 twice, so really upside down. And I find my original A and go treat this as my new X and this as my Y. So it's the same X and the same Y, except upside down. And we're going to go 1, 2, left 2, and then down 3 boxes. So -2, -3. So then I flip back to home position and I plot the point -2, -3. And it should be in a straight line right from that original. And that's going to be our triple prime. And this one was a double prime. So you can see 180 degrees, it's on a straight line. This one, if you connected our 90 degrees, should be a nice 90-degree angle created with the origin. So here are the rules. You are welcome to graph these like we just did every time and figure out the rule. Or if you prefer to memorize it and go a little faster, that's fine too. It's just more studying and memorizing. So if you have a rotation about 90 degrees about the origin, the new ordered pair would be -y, x. So here, like this one, you'd switch them and negate the y. So the 3 comes first and negated. Also something to note here, if you had a rotation about the origin of -270 degrees, that would be the same. If I rotate about the origin -90 degrees, the point xy, so that's like letter B here, we switch the order, so it becomes y, and then we negate the x, so see the 2 became negative. And that would be the same as rotating positive 270 degrees. Notice together they add. So now we're going to take rotation of about the origin of 180 degrees. And notice here we just negated both. So that's the same as -180 because the sign doesn't matter with 180, or also it's the same as the reflection over the origin. So again, you can choose to memorize these rules if you would like. You do not have to. You can always just graph and turn your paper. So those are the rules there. Okay, let's do another practice. This one's a little bit different. So given a square A, B, C, D, find each of the images. So here's my square. Need to go over one more. And here's my center point. Connect my diagonals. We'll call this point E in the middle, and this is A, B, C, D. Now we know that diagonals bisect each other in a square, and diagonals are also congruent in a square. So all of these little segments, E, C, E, B, A, E, D, are congruent. We also know that in the diagonals in a square are perpendicular to each other. So we know that we have right angles at the center. I want to rotate about point E 90 degrees. So 90 degrees would be counterclockwise, the point A. So I'm going to take A right here, and I want to rotate it 90 degrees counterclockwise. So about point E, so I want to make a 90-degree angle with E and go the same distance from E. So A is the same distance from E as D is. So A, if I rotated about point E 90 degrees counterclockwise, I would end up at point D. Try another one. If I rotate about point E 270 degrees, the point B. Again, this is counterclockwise 270, or that'd be the same thing as going negative 90 degrees. So if you add 270 plus 90, that gives you 360. So you want to just go in the opposite direction. All right, so we're looking at point B now, and we want to go 270 about point E. So that's 390 degrees. So we want to go counterclockwise. So here's 90 degrees counterclockwise once, twice, 3 times. So we end at C, or negative 90 would be going counterclockwise 90. So either direction you go, it would be C. Next, we're going to do a couple more practice. So again, the series of events that should be happening here is that you're going to graph your original point, turn your paper, write down the coordinates, and then turn your paper back to home position. And that's when you want to plot the point. Okay, so the first one, I want you to rotate about the origin 90 degrees, the point 5, negative 2. And we can call these A, B, and C. So I think it might be easiest actually if we just do one grid and we can plot them all on that. So you're going to want to make sure you can go up 7 is the most and over 5. Okay, so that's my y-axis and here's my x-axis. Okay, so the first one we're rotating 5, negative 2, 1, 2, 3, 4, 5, negative 2. Let's call that point A, since we're using letter A here. So A, if I rotate that 90 degrees, so here would be a good place. We've done this one already, so 90 degrees. Pause the video, see if you can get the answer on your own. Okay, so what you should have done is rotated your paper 90 degrees counterclockwise, then found the new coordinates, which would be over 2, up 5. So the coordinates for A prime would be 2, 5. So A prime is 2, 5. Plot that. 1, 2, 1, 2, 3, 4, 5. Again, if you connect it to its center at the origin, you created a nice right angle going counterclockwise. B, I want you to rotate about the origin, negative 90, the point 3, 7. Pause the video, go ahead and try that. Label this one B. So B is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Rotate it negative 90, so that tells me I want to go clockwise 90 degrees. And then I'm going to go over 7 and down 3. So that would give me the point 7, -3, and let's plot that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 is B prime. Again, if you connect it to the origin, you'd create a nice right angle. And the last one I want you to do is rotate about the origin 270 degrees, the point 1, 0. So again, let's plot 1, 0, label it C. We're going to rotate 270 degrees, so counterclockwise. So we've got 90, then we have 180, and then we have 270. Or you could have just gone 90 degrees clockwise. And here we find our point C, and it's the point 0, -1. So 0, -1 would be C prime. Again, you can see right on there how it's a nice right angle that happens there. Number 4, find and state the coordinates of the image of triangle DEF with coordinates D at -5, 2, and you're going to want a graph for this one. E, 4, 5, I'm going to run out of space. F, 0, -3, after a rotation of 0, centered at the origin, -100, 180 degrees. So here, again, you can graph all of this out. Graph, or you can also memorize the rules. That's up to you. If you're going to memorize the rules, you need to take the time, though, to really make sure you know them. All right, so for each of these, I'm going to set up my graph. Here's X and Y, and this is number 4, continued. So graph my D, E, and F, 2, 3, 4, 5, up 2, 1, 2, 3, 4, up 1, 2, 3, 4, 5, and 0, 1, 2, 3 is my original. So all you're going to do now is just take each of your 3 points and you're going to rotate them. So we're going to take point D, and we actually can spin our paper once and write down all of the coordinates all at once and then plot them all at once. So let's take our paper and we're going to rotate it. We want to go -180. So we're going to go clockwise. There's clockwise 90, clockwise 180. Looking at my new x-axis, my new y-axis. The coordinates for D, I'm going to go over 5, down 2. So over here, I can write these in. So D prime would be over 5, down 2. E prime, I'm going over to the left, 1, 2, 3, 4, 2, 3, 4, left 4, down 5. And F prime, we're going left, right, nothing, so 0, and then up 3. So once we have that, you're going to flip back to home position again and plot your points. And I'm actually going to let you guys do that on your own. So if you want to pause, plot your 3 points, connect them, and you should see your nice 2 triangles. They will be overlapping a little bit once you plot them, and that's okay. And that's all you'd have to do is make sure you write down your coordinates and show your graph. Okay. And next, we're going to rotate around a point that is not the origin. And this is probably the hardest thing to do. Rotate around a point that is not the origin. So number 5. rotate the point M, 3, 5, 90 degrees clockwise about the point C, which is -1, 2. Started to write a parenthesis there. Okay, so here's what we're going to do. First, we're going to start by drawing our axes. I'm going to write out all your steps that you guys are going to need. All right, first thing I want you to do is plot your point and the center point. So I've got the point 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, and that's M. And then my center is -1, 2, label that C. Step 2, I want you to make a new set of axes with the center is like your new origin. Okay, so this sometimes it helps me to use different color here. So I'm going to take C, which is my center point, and let's do pink. And I'm going to make, I'm just going to draw a new set of axes, so as if C was my origin. Okay, now what I'm really doing is I'm pretending it's the origin, and I'm going to rotate this point as I would about the origin. So now, for step 3, I'm going to rotate my paper and write down my new coordinates. Okay, so here's M. So I want to rotate this one 90 degrees clockwise. So I'm going to go 90 degrees clockwise. And using my new axes, I want to figure out what the new coordinates are. So 1, 2, 3, 1, 2, 3, 4. So right 3 and down 4. Okay, right 3, down 4. So you can write that down. Or you can just remember it. And then we're going to, so 3, -4, we're going to flip it back to home position, and we're going to plot the point on our pink axes, 3, -4. So 1, 2, 3, down 1, 2, 3, 4. M prime. So that's where our point would be if our axes, if we rotated it 90 degrees about the origin, if the origin was the center of these pink axes. So our answer is not 3, -4. Our answer is what the new coordinates are on our original axes. So here we went over 2, down 2. So M prime is actually 2, -2. Okay, so we rotated the paper and wrote down the new coordinates. We plot using the new axes, using the new axes, so the pink axes on my paper. And then you're going to write out the coordinates. And here's where it tricks people, because they forget to use the old axes. Okay, so we do it all on the pink axes. We rotate it, we figure out the new coordinates, we rotate it back, we plot it on the pink one, but then we tell what coordinates it is using the black axes. Okay, let's try another one of those. So rotate the point G, -3, -2, -270 degrees about the point P, which is 4, 0. Okay, so see if using the example in 5, see if you can do that one on your own. So pause it and then check back here for the answer. Okay, so because this is tricky, I want to go through this one completely again. So first I'm going to plot the point -3, -2, and that's G. And then my center of rotation is 1, 2, 3, 4, 0. So at P. First thing I'm going to do is create a new set of axes, making P my origin. So here are my pink axes. So the x-axis is still the same. And then I'm going to rotate this -270 degrees. So that's the same thing as also rotating it 90 degrees. So positive 90 degrees would mean I would go to the counterclockwise, 90. -270 would be 3 turns to clockwise. Either way. Now let's figure out what our coordinates of G are. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So write 2 down 7. That's 2, -7. So if you need to write that down, you can. Then you're going to go back to your pink axes and go over 2. And I think I'm going to be a little short here. 1, 2, 3, 4, 5, 6. I need one more. 7. I'll show you just here. I'm going to extend it. 6, 7. And that would be my G prime. To figure out my answer now, I'm going to go to my black axes and count 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6, 7. So my new coordinates of G prime are over 6, down 7, not this point. And that would be your final answer. Hopefully you got that when you did it on your own. All right, so very tricky. Make sure you go over those. Let me know if you have any questions. Try them back again on your own if you need to. And that is it for me. Have a great day. And pie out.